Moin and welcome back. In this video we will have a look at sets and dictionaries, which are also very important container data structures in Python. So let's jump in. In the previous videos we had lists, and you remember maybe for the list we could put in arbitrary type of elements into the list and they were identified by their position. For dictionaries it's a little bit different because the elements are not identified by their position, but to every element you have also to provide a unique key which basically identifies that element. This unique key can be anything as long as it's of immutable data type. So let's have a quick look at that. How do you do that? Dictionaries, in contrast to lists, which used square brace, dictionaries are using curly braces as delimiter. And if I want just to create a dictionary D here, then I'm just writing a curly brace here and a curly brace here. And between the curly braces, I can specify the content. And I have always to specify a key and the value pair. The key is the key which identifies the element, the value which is associated with the key. And basically you separate the key and the value by a colon. And then you separate the item pairs by comma, right? Also here, I have the second key, which is the string test2. This is immutable, so it's all fine. And the value associated with that is the string hello. Here, the third element which I have is has a key 12. 12 is an integer, this is an immutable type, so it can serve as a key for a dictionary element, and the associated value is the list 1 and 2. Lists are mutable, but it's not a problem because I'm using here as a value, not as a key, and the value can be arbitrary. If you execute that in your Jupyter notebook, then basically you will get here a new dictionary where here you see the key and value pairs accordingly. So how do you access the elements in the dictionary? As I said, there are no positions, there are only keys. So basically, if you want to access the element, the value of the element, which is associated with the key test1, then you have to write dictionary, and then the usual square braces, like for lists, and then you specify here the key, and then you get the associated value, which is 1. Similarly, if I want to have here the value which is associated with the key 12, then I'm just writing the dictionary name and then the square braces and 12, and then you get here the list 1, 2, which was stored in the dictionary. Okay, dictionaries itself, similar to list, are mutable. That means they can be modified, their content can be modified after they have been created. So for example, if I want to change the value which was associated with the key test1, originally it was, if you go back, you see that originally it was just the value 1, the integer 1. Now if I want us to change it to the, let's say to a complex number 3 plus 4j, then I just write d and the key and then equal 3 plus 4j. And then if you print out the dictionary, then you see that the corresponding value had been changed accordingly. You can also extend the dictionary. So basically, if you are setting a value for a key, which doesn't exist in the dictionary yet. For example, here I'm using the key, which is the tuple containing a single tuple containing only one element, the element -1, and I set it to 12. Then basically this key didn't exist, and then suddenly at the end of that here, the last is as a last item, you have the according key value pair. So you can extend dictionaries just by setting a new key for which is not there yet. You can also shrink the dictionaries. You can delete elements from the dictionaries using the del statement, and the syntax is similar to what we had in list. So basically you are specifying the element, the dictionary, and the key which you want to delete, and then as you see here, then the according key value pair vanished from the dictionary. We can also use the in operator in order to test the presence of a key within a dictionary. For example, if I'm testing whether the key test1 is present in the dictionary, then I get true because yes, this dictionary had this key. Or if I'm trying to look for a key which is not present in the dictionary, then I would get false. What you should not do is try to access an element in the dictionary or a key with a dictionary which is not there yet. So basically, if you try to print out the value associated with the key missing, we did not declare a key missing in the dictionary, therefore basically you will get a key error. So basically this is something you should avoid because it will result in an exception. However, there's a way to circumvent that. If you don't know whether the key is there, but you say, okay, if this key is not in the dictionary, then give me a certain default value instead, then you can use the sort of get method of the dictionary. So basically you take the dictionary name, then the dot operator, which we will discuss later more in detail, and the get method of the dictionary, which basically operates on the data which is stored in the dictionary D. It looks up whether the key which you specify here is present in the dictionary, and if yes, you would get the according value. If no, you would get the default value instead. So basically that's a nice thing, then you won't get an exception. And here, because the key missing is not in the dictionary, we are getting the value -1. And actually, if you wanted to write this code in Python, you could yourself, but of course it would be much more verbose. But basically this thing, what we did here, is equivalent to this code here. So basically, if the key is in the dictionary, then give me the value corresponding to this key. Otherwise, give me the default value which I provided. Okay. Dictionaries itself can be also used as an iterator, so you can iterate over dictionaries. So basically just let's assume our dictionary D is this dictionary here. If I'm writing a list where I'm iterating over the dictionary, just using the dictionary here as the iterable object, then basically I'm not doing anything else, just iterating over the keys of the dictionary. So basically at every iteration in this loop, I will get the next key in the dictionaries. And if you would print that, then you would here basically see exactly that in your Jupyter notebook, for example, that for every key you get the every key you get here. Sorry, for you get all the keys here, right? Okay. If you want to get for every key, or instead of the keys, you want to get the values, then you have to specify another iterator, which you get with the values method of the dictionary. And basically, if you iterate over this one, this gives you an iterable object. If you iterate over that, then you get the values of the dictionaries one by one. So in this case, if you would print that, then we would see 3 entries, and not the keys, but the values instead, which we declared in the dictionary. If you want to have them both, keys and values, then basically you can use the items iterator, which is presented here. So basically this gives you an iterator. At every iteration you get a tuple with 2 elements, and you can unpack this tuple with the 2 elements. The first element will be always the key, and the second element will be always the value. So if you want, you can already unpack it into 2 variables and use these 2 variables to access the key value pairs of the dictionary. So here I'm printing the key, I'm printing a column, and then I'm printing the value. And you see, you get exactly that. What would you accept? You get basically the key item pairs of the dictionary printed. So those are the most common methods to iterate over dictionaries. How do you create dictionaries? You can create dictionaries by the curly braces. Actually, if you use curly brace opening and closing curly brace just itself, then you get an empty dictionary. Or you can basically here add also immediately content by specifying key, colon, and value, and then comma, and then again key, comma, colon, value. You can also create a dictionary from an iterable object as well. This iterable object, for example, a list, must then contains key value pairs as tuples, basically, right? So here I have a key value pair, A, and 1, a key value pair 3.2, and the string hello as the second tuple. And if I just, this is a list of tuples, and if I just here basically do the dict method on top, so basically apply the dict function on that, then I get a dictionary which contains exactly the keys and the values as specified, right? Okay. You can also use dictionary comprehension like we have seen for lists. That means that you can create a dictionary on the fly because you need key value pairs. Therefore, in the expression part of the dictionary, you need a key expression, a colon, and a value expression. So here I am just using a num, the variable a num as key, and the square of the variable num as value. And then I let num, the variable num, run over all the items in the container in the list containing nums. And then just to filter, this is an optional filter, of course, but here I can filter. I add an additional filter like we did for the list. So if I say only include that item if the number is not divisible by 2, that means that if you divide it by 2 and take the remainder is 1. And this will basically then contain here 1, 3, and 9. Those were the numbers. Those were the numbers here, which were here the odd numbers. and their squares, right? So 1 to the square, 3 to the square, and 9 to the square, because here that was the value part. You can also see that here 3 is given here 2 times, right? Here and here. But we know that the keys in the dictionaries must be unique. So basically, when you specify the same key again, then it will be just overwritten. So it will be contained in the dictionary only once. Okay. Now we would like to look at something different, or very, very similar actually, the sets, which is also a container in Python. And this is very, very similar to the dictionaries. The only difference is that you have you can think about sets like dictionaries, which have only keys but no values. So basically, actually, this is also how you write them. If you want to create a set, basically here, then you with the curly braces, and then you are just adding immutable entries, which for a dictionaries they were keys. Here they are just members of the sets, and sets can be very good. Basically, then when you then here output the set, then you will see that you get back exactly that set. With the difference that the order of the elements is not the same as you have specified here. And basically for sets, Python does not give you any warranty that the order of the elements is the same as how you put it in. So think about sets as unordered. You can extend sets once they have created. Sets are mutable, so you can add new elements with the add method. So if I want to add the element true, the logical true, which is also an immutable data type, the logical true, therefore I can add it to the set. Then you see that it suddenly appears here in the middle, so it's not necessarily the last one. As I said, the position doesn't make any sense in sets, they are unordered. If you are adding an element which is already there in the set, so which had been before already declared, then nothing happens, it will just be still in the set. So the set is a container where something can be either in the set or not in the set, but then that's the only information basically you get. There are no other information associated, just the presence of the entry in the set or the presence that it's not in the set. You can of course also remove elements from the set with the remove method of the set. So for example, if I wanted to remove a certain element, I can do that without any problems. And again, you can use the in operator to check whether a certain element is contained in the set. So basically here I'm checking whether the element 12 is contained in the set, and that's the case, and therefore I get true. And then I'm checking whether the element 13 is in the set, and that's not the case, and therefore I get false. Okay. Also, sets can be used as iterators, so you can iterate over sets, and basically what you would get is that you are iterating over the entries in the set. So here I have a for loop where I call the iteration variable item, and the iterable object, the object I'm iterating over is the set, and then I'm printing basically just a string item, and then the item itself which I obtained. And you see that you get here one by one the elements in the set, right? So you iterate over the elements which are contained in the set. As I said, the order is undetermined. So basically you see here I was specifying true first, and then 12, and then test, but the order how I got them back is different. So basically do not rely on any order in sets. And actually, although in dictionaries you can rely on certain orders, it's better also to think about dictionaries most of the time as being unordered. How can you create sets? Sets you can create, as we have seen already, with the curly braces, and then specifying the elements which are part of the set, separated by comma. Also, you can create, similar to dictionaries, also you can create a set using the set method from any kind of iterable object, and then basically set will iterate over the elements of the object here, this list, and every element of the iterable object here, every element of this list would be accordingly a new element in the set. And again, very similar how we did that for dictionaries, we can do it also for sets, making set comprehension expression, curly braces, then I have any expression you like, then closing curly brace, and then here an implicit for or a for loop within with an optional filtering if you want to filter on that. So if you wanted to store the squares of those numbers which are here in this list in the set, then I would just make the num square here. So basically num to the square for each value of num which it takes when it runs over all elements of the lists, but only if the number itself is not divisible by 2. That means the remainder by a division of 2 gives you a remainder of 1. And as I said, the if is optional. If you don't want to filter, then you can just leave it away. So now that we have basically covered very, very quickly the 3 most important types in Python, container types in Python, the lists and the dictionaries and the sets, it's maybe a good time to have a quick look at that and compare them. When should I use which one? We have said that lists are ordered. That means elements are basically always in the same order how you put them in. And they are indexed by the sequential integer, which is basically their position. So when you put something on the position 10, then you can just ask for the 10th element and you get exactly that element. However, be aware of that the index of the given element might change when other elements are inserted and deleted, right? So if you have the list 1, 2, and 3, and you are inserting a new element, and then suddenly you have the list, let's say 1, and here you insert the element 10 and 2 and 3. Then suddenly the number 3, it's not on position 2, but on position 3 in the list, right? So if you manipulate the list, the access point of the elements, the integer of the which identifies the elements, might change. It's super fast to ask for an element by their position. So basically order 1 means that it's basically the time you need for that is almost independent of the size of the list, right? However, if you want to check whether a certain value is contained into the list, like the in operator, what we did, right? Then it's super slow if the list is very big. So be careful with that. Dictionaries are unordered, although for Python versions 3.0 or 3.7, sorry, they have a certain order. So basically you would get, when you iterate over the dictionary, you would get the elements in the same order as you put in. But most of the time it's better to think about dictionaries as unordered. The elements are indexed by keys and not positions. Keys can be any immutable object. And the good thing is that this index, even if you manipulate the dictionary and you add new elements to that, the index will not change because this is not a position, but a key, which is always remains coupled with the element. If you want to check the presence of a key in the dictionary, that's super fast. So basically it's independent of the size of the dictionary. If you try to look for a value, then of course again the Python has to go over the entire dictionary, and that would be somewhat slow. Sets are the special case of dictionaries. They are definitely unordered. There is no guaranteed ordering in Python. And the elements in the sets are unique, like keys in the dictionaries must be unique, elements in the sets must be unique. There is only one element, an element can be there only once. And the good thing is that again, that checking the presence for an element in the set is roughly independent of the size of the set. So basically you would use a list when the position index, it's a very important thing, and the elements must be unordered. Otherwise, you can use dictionaries, and if you only need keys, if you need only values, but so you don't need key value pairs, just checking whether a certain element is in a set or not in a set, then you can use a set for that, apparently. I also want to demonstrate that for you. So basically we can make a quick exercise, and for that I will just change to Jupyter Notebook and try it, demonstrate it to you. I have here the max number. This is the number of elements which we are generating for a list, and the set, I have set it to 10 million. Maybe you should try with a lower value for your machine just to make sure that you don't get any issues with the memory. But basically what I'm doing here is I'm just importing the random module here, and I'm creating a random list by just creating random integers. So basically from the random module we are taking the function randint. This is what this dot means. So from the random module take the function randint. The randint function takes two values, the lower value and an upper value, and it would generate you a random number in this range. And I'm doing that max num times, so 10 million times. So basically when I execute that, it will take a while. I will get a list which contains 10 million random numbers. So it takes a little bit on my laptop, so we have to wait, but now it's ready. And if you just check how long the list is, the random list, that is 10 million entries, okay? And maybe we can just have a look at the first 10 elements. So when you say random list, let's say have a look at the first 10 elements, and you see that those are some arbitrary random numbers in this range. Okay, let's do the same for a set. So we are creating a random set, again, from random list. So we are taking every element from random list and adding to the set. Now let's have a look at the size of the set which we got. I definitely will not print the entire set, that will be a bit too big, but let's have a look at the size. And the size, you see, it's somewhat lower. It's only 6 million something. Why? Because of course when I generated the random numbers, they are duplicates, and we know that in sets there are no duplicates. So basically you can add one element, a certain element, only once to the set. It cannot be in the set several times, but it's roughly the same size. It's more than half of the same size. Now let's do the following. We are looking for an element in the list which we know that it's not there, right? So because we were generating here random numbers until max num plus 1, max num, therefore max num plus 1 is not in the list, and that's time, how long it takes to check whether this thing is in the list. And basically Python just executes it and says, okay, it was for every query it was roughly 185 milliseconds. Okay. Now let's do the same and checking whether the number, this number which we know it's not in the set, whether it's present in the set. And then basically if you run it and make the timing and that Jupyter Lab time it, then you see that we had 185 milliseconds here, and I have only 17.3 nanoseconds. So I am more than almost 3,000 times faster, right? And this is something you should keep in mind if you have very, very big structures and you only want to check for the presence of the certain item in this big structure. Then a set can be several thousand times or even more faster than a list. So please use a set if it's only about checking a presence of an object and the objects are immutable. Okay. The last thing we want to have a look at is the comparing containers, and basically here you can compare containers whether they're equal or unequal. And when are two containers equal? Of course, if they contain the same elements and the relevant keys or indices are equal. So for lists, it will be very trivial if the elements are in the same order in the two lists and they are exactly the same elements in the same order, then they are equal. For dictionaries, it's a little bit more tricky because let's have a look at this interesting example here. I am creating a dictionary with key 1 and 1 as key value pair and key 2. The string key 2 and 2 as value. And then I'm creating the same dictionary on the right hand side, but with the same key value pairs, but in a different order. So I'm specifying key 1 first and then key 2 first and then key 1. And I'm asking Python whether the same are true. And if you just try it in your Python environment, you will see that Python says true. So basically the order in this case doesn't really matter. Although dictionaries are ordered in recent Python versions, nevertheless at comparison the order doesn't matter. Of course, if you are changing here the element, the value associated with key 1, and this differs from the value associated with key 1 in the other dictionary, then of course you would get false. You can also, if you have ordered sequences, so like lists and tuples, but of course not dicts or sets, then you can compare them also with the greater, equal, less, and less equal operators. So basically you can ask whether something is greater or bigger. And the interesting question is what happens if this tuple has multiple elements, for example here, and you go, that's the tuple 1, 2, and 3, and you compare it against the tuple 1, 2, and 4. So how would Python do that? And this is basically Python would always first have a look at the first element. And the first element in this case is equal for the two sets. So it cannot be decided whether the left tuple is greater than the big one. So the Python would go to the next element, which is 2. However, unfortunately, the next element is also 2 in the tuple on the right hand side. So Python still cannot decide which one is the bigger. And then Python would go to the third element, and because the third element here differs from the third element on the right hand side of the comparison, then it's easy to look whether 3 is greater than 4, and that's not the case, and therefore you would get Python would get false. So basically the comparison is component wise as long as it cannot be decided uniquely. So basically as long as Python doesn't reach the first non-matching component. You can do similar things with strings. as well. For example, here I have a tuple which contains a string and a number, another tuple which contains a string and another number, and I'm comparing them with the greater operator. And indeed, the string hello, I mean, Python would compare it component-wise. The first component here is the string hello, the first component here is the string ahoy, and basically strings are again compared element-wise, so that means every character-wise, and age, the character age is greater than the character a, so basically you would get a true. This is something you can use quite nicely, for example, also sort when you sort, because the sorting order would be defined exactly by this kind of comparison. So let's assume I have here again the list hello and the number 6, so a list containing a tuple hello and 6, and another tuple containing the string ahoy and 9. And then basically that could be, for example, let's say I was counting words in a text, and the word hello was occurring 6 times and the word ahoy was comparing 9 times. And now I would like to print out, let's say, the list for every word, the occurrence, but the words should be sorted alphabetically. Then I can just sort the entire list, and because Python is doing the sorting component-wise, it would compare the strings and then sort the tuples based on their first component, the string component. So you will get basically the tuple, which the string, which is the smaller in a comparison ahoy as first, with the corresponding number, which was in the same tuple, and hello, which is the second string, and the corresponding number. So basically Python would always basically sort the elements together, so it won't change the content of the tuples, but they would be sorted tuples based on the first component, or if it's not unique, then based on other components. Okay, and this is roughly what I wanted to tell you about containers in Python.